Chapter 4 Review, Practice Problem 29. You are piloting a small plane and you want to reach an airport 450 kilometers due south in 3 hours. A wind is blowing from the west at 50 kilometers per hour. What heading and airspeed should you choose to reach your destination in time? In order to solve for this following problem, we're going to label the following. We know that in order to solve, we're first going to draw out the following that we have. We know that the airport is 450 kilometers due south. We also know that in order to travel due south, it's going to take us 3 hours. We know that velocity is equal to displacement divided by time. Therefore, the velocity due south is equal to 450 divided by 3, which is also equal to 150 kilometers per hour. Therefore, we can solve for the velocity traveling directly due south is 150 kilometers per hour. We also know that the wind is blowing towards the west in 50 kilometers per hour. The question is, what heading and airspeed should you choose to reach your destination in time? Airspeed is going to include the resultant. If we have sides 150 kilometers per hour, and we have 50 kilometers per hour as the displacement, we are able to find the resultant. We're going to use and solve for the following. A squared plus B squared is equal to C squared, the Pythagorean theorem. We have the two sides, therefore we can solve for the resultant, or C squared. C squared is equal to 50 squared plus 150 squared. C squared, therefore, is equal to 50 squared, or 250,000. C, therefore, is equal to 158 kilometers per hour. We know the resultant now to be 158 kilometers per hour. Now we calculated the airspeed. We need to know at what heading. So what is the angle that we're trying to solve for? Now, we know that in order to travel south, that this angle right here is what we're trying to solve. We know that this is a right angle, but we need to know at what angle should the tip or the nose of the airplane be angling at in order to travel down. In order to solve for that, we're going to take the following. If we have, SOHCAHTOA, I can actually take the tangent of the angle is equal to the opposite over the adjacent. Tan of theta is equal to opposite over adjacent. Therefore, we are able to take tangent of theta is equal to the opposite, or 150, over the adjacent, or 50. In order to solve for theta, I can take the tangent inverse of the sides, 150 over 50, to find or solve for theta, which is equal to 72 degrees southwest. Now we know that 72 plus 72 degrees is equal to plus 18 is equal to 90 degrees. If we have the 72 degrees, we're able to solve for that we need for this right triangle. If we have this difference over here of 72 degrees, the rest, this angle right here, is what we want the tip of our nose to be at. Therefore, the flight is straight, but the plane is angled at 18 degrees.